When the holiday season rolls around, are you the sort of person that likes to give and receive Ethereum instead of presents? Well, if you're sending around a raw Ethereum using Brownie or smart contracts, there's a few pitfalls you might want to be aware of. Handling raw Ethereum is something that commonly trips people up when they're using Curve. So we're at a good point to illustrate this using our Margarita smart contract. We've got our smart contract working with DAI, an ERC20 token. Here you see the test we're currently skipping. We're going to copy this test, but we're going to use it to try and deal with, instead of DAI, we're going to try and deal with raw Ethereum. And instead of this being an integrative test, for now, we are not going to loop through all the pools. We're just going to look at one pool we know happens to work, and that's 13. That's a pool that handles raw Ethereum. First thing you'll note is we don't have a fixture to provide the Ethereum address. So we're going to have to look at our conf test, and we're going to have to look to where we're currently pulling in DAI. It's a good function. It mints DAI for us. It's a useful fixture. But we'd like to return Ethereum. So we'll look at the registry contract to get this address. And what we're going to do is we're going to use the registry. It has a get coins. And we're going to pass a known contract that has Ethereum in it, Seth, where it exists at coin slot 0. Now, we don't need to mint new DAI. Alice should automatically have DAI. We'll go ahead and check this. Alice is an unlocked account, which means there's access to certain functions that deal with Ethereum. One of these functions is balance. Another is transfer. In previous units, we showed how you can unlock any account by passing the force equals true. And this is going to give you these native Ethereum processing capabilities for any address. So with this locked and loaded, there's not too many changes we need to make. We don't need to deal with this. This was a test when we were integrating over every pool. Final thing is Ether does not have a balance of function. So our final test would be, for example, does stake balance equal 0? Does Alice's balance equal 0? If so, then the F has to have gone somewhere. It would have gone into a Curve pool, and the stake would have a liquidity pool or rewards token. So what happens if we try and run this test? We'll pass it in interactive mode. So if it fails, we'll land on the command line and be able to debug things. And can you see why this is going to fail? Because it will fail. We're trying to deal with raw Ethereum. And in this case, we're trying to transfer it as if it was an ERC20 token. But Ethereum is not an ERC20 token. It's just this raw address. We try and wrap this into a contract. There's no contract that exists. It's basically, you can think of it as a placeholder address signifying that this is trying to deal with raw Ethereum. And as a result, we're going to need to deal with it much more appropriately. Instead of trying to transfer it here, we could try and just transfer it directly. So for example, Alice, we know that she has a balance. Alice also has this transfer function, so she could send accounts to her entire balance. And now Alice no longer has a balance, but accounts 2 has a balance. So that's one way we could theoretically do it. We could transfer Ethereum to the staking contract, and then the staking contract can stake it. At the moment, though, you would find that if you just tried to transfer directly, it's going to fail. So if we send to our staking contract the accounts to full balance, it reverts. A smart contract needs to have a function that handles it when it receives raw Ethereum. Otherwise, it triggers a revert. So if you want to go this route, which is a viable route, you would just need to modify your smart contract to include logic to handle raw Ethereum transfers to it. We're going to attack it a slightly different way. We are going to adjust this to send the Ethereum with our staking.ape call. The .ape is the function that we use to say, go ahead and get into a smart contract. We've previously seen in Brownie, you can pass a dictionary of parameters. Usually we've been passing the from address that's calling it. We can also pass a value. So we're going to send along Alice's entire balance of Ethereum when we call this staking contract right here. And if this works, then we have every reason to expect that any failure that occurs here is not a failure in our test, but a failure in our actual smart contract. So let's go ahead and get the staking contract up and take a look, because it very well should fail. And we see, in fact, the very first issue we're having is that we can't send Ether to a non-payable function. When you're dealing with Solidity or Vyper, anything using EVM, if your function is not explicitly marked as payable, it cannot receive raw Ethereum. So now it can. When we rerun this again, you can see where the interactive mode with Brownie is great because it gives you a bit of debugging information, and it drops you on the command line with all of the parameters, so you can experiment and explore, poke and prod it, and figure out what exactly is going wrong and call the contract, figure out how you can fix it. So let's see where the next issue is. It's saying it doesn't like this line here. This is line 120 in our staking contract, and you can always get this sort of callback information by calling a traceback on the most recent history message. So line 120 is our problem. Sure enough, as soon as we get into this add liquidity function, first thing up is it's trying to call a balance. This works great if our coin was an ERC20 token, but our coin is not. We're going to modify this a little bit. First, we're going to set coin balance as 0. Then if our coin address is equal to the placeholder Ethereum address, then we're going to say our coin balance is equal to simply the amount of Ethereum contained in the smart contract. Otherwise, our coin balance is pulled as normal. And we could continue doing it this way, just seeing what's going to trigger. Eyeballing it, we can see we're going to run into trouble here. Anytime we're calling an ERC20 function on Ethereum, it's going to fail. So we'd want to adjust this. If coin address, again, equals, and I just realized I need these single quotes here. Coin address equals Ethereum, rather, does not equal Ethereum. And we'll go ahead and call the approval. Raw Ethereum doesn't need approval. Last place where this is going to come in perhaps handy is, I'm not exactly sure which of these functions we're going to need to change. We might well need to change all of them in the end. But let's see which one of these we need to specifically tweak just for now to get things working. Because at this point, our logic is forked into calling several different interfaces for 2 pools, 3 pools, 4 pools. And if we don't know which one specifically is failing, we don't want to split our logic for all of these just yet. Now we're going to want to improve this logic just generally to make it more generic. But here we see that the issue is coming in at line 144. So it's this line here that's giving us a problem. And what's basically going on is, if we look at our definition of this curve 2 pool, add liquidity is a non-payable function. So just for now, we'll fix just this one. We're going to say it's a payable function, and we're going to send actual raw value of Ethereum transacted. In other words, if our coin address is equal to this address, we're going to send Ethereum wired up with our call. Otherwise, we're going to call it like normal. So within Vyper, it's pretty easy. If you're dealing with a payable function, you simply pass a value equals and then the amount you like to do. We're going the balance of the contract. If you're dealing with Solidity, there's a slightly different syntax. So check out the notes in our GitHub repository to see how you wire raw Ethereum using Solidity. If all goes well here, and who knows, getting late in the day, so there could be some typos. But if all goes well, we're going to expect this loads, starts running our tests, and we'll see if this first test passes with a wonderful dot. The fact that it's taking some time, hopefully a good sign. And we passed the first test. Congratulations. We've very quickly modified this contract to now accept raw Ethereum. Of course, we want to make this thing a lot better before we publish it, but looking like we're going in the right direction. Hopefully this is useful if you're trying to send or receive raw Ethereum.